Hello guys, good evening. Good evening all, good evening and welcome to day 3 of our Generative AI Masterclass. Good evening. Am I audible? Can you see my screen? Yes, good evening all. Very good evening. Good evening. Very good evening all. Yes, good evening, good evening, good evening everyone. Very good evening and welcome dear participants. Good evening and welcome to day 3 of our Generative AI Masterclass. Just to confirm whether is everything fine, can we start with the session? Can we have a recap of what we have seen in the previous session? Thank you all for joining for day 3 of Generative AI. Thank you for the confirmation of screen visible and voice clear. So we'll start with day 3. So before that, can I just know that what we have seen in day 2? Just a recap, can anyone please give me what we have seen in day 2? So in day 2, we have discussed about the basics of Pytorch. We have seen a lot of methods and terminologies inside of it. So what is a tensor, how to create a tensor, how to find the dimension, the shape, the other properties, okay, how to reshape it, how to stack it, how to add GPU to your tensor, and all those things we have discussed in the previous session. So in this particular session, we are going to, hands-on with PyTorch we have seen, right? So this session, we will be having a theoretical session, and most probably this will be the like final theoretical session first and last, because from the next session onwards we'll be having like hands-on creating neural networks, and then going with projects on neural networks, and then jumping into generative AI and computer vision and so on. Okay, so in this particular session we are going to discuss about theoretical and math behind deep learning concepts. But before jumping into deep learning concepts, we are going to see two major machine learning uh, models or algorithms. Okay, so this is one of the, it's not just machine learning algorithm, it's one of the basic properties of max. Okay, so what's the reason behind this, or why we are learning this linear and logistic regression is, so once you understand this, it will be better for you to understand a lot of concepts inside of deep learning, as in the case we move forward with classification as well as regression. Okay, so this linear and logistic regression will be dealing, and then we'll be jumping into deep learning concepts, and this will be a small glimpse. So we'll see into what is linear regression. Have anyone heard it before, like in statistics or maths or even in machine learning? What is linear regression? Any idea what is linear regression is? When we talk about this linear regression, so let me take you and tell you the math behind it. As we know, in machine learning, we have different types of machine learning, like we have we have supervised learning, unsupervised learning, and reinforcement learning. So now our focus will be mostly on supervised learning. Okay, so we have in supervised learning, we have labeled data. So in that labeled data, we have two types. We have classification as well as regression, right? Okay, so when we talk about classification and regression, the target or your output changes. I have told you with a simple example of whether the temperature is going to be hot or cold, or whether the temperature is going to be this particular temperature. Okay, so in such cases, linear regression is an algorithm which is used for predicting regression values, like a continuous value. Like for example, what's the temperature, whether it's 82 or 83 or 83.2, that particular value you are pinpointing, right? So that is done with the help of linear regression. So what is this linear regression is? So linear regression is a popular and widely used supervised learning algorithm in machine learning. It is a statistical method which assumes a linear relationship between the variables, meaning the relationship can be represented by a straight line on a scatter plot. Okay, so the linear regression can be used for prediction of dependent variables with one or more independent variable. So what is that? Let me show you with a simple example. So this is what a linear regression is. We are plotting a scatter plot and trying to fit them with a straight line, okay, which will pass through most of the points. Okay, so we have independent variables and dependent variable. Independent variable is going to be your features or your values in your data set or your features of your target, and dependent variable will be your target, like what is the temperature exactly. Another example for linear regression is this part. We have rainfall in x-axis and we are going to predict our target, which is umbrella sold. So when we look into this data, when the rainfall increases, I could see that the umbrella sold is also increases gradually. Can you guys see it? When the rainfall is around 90, we could see that the umbrella sold is 20. Similarly, when the rainfall increases like around 170, we could see the umbrella sold also increases. Okay, so this is what independent variable is, and these are the dependent variables as umbrella sold. Okay, so we are just trying to fit the point. For example, from my data set, I am trying to fit all the points, and what I am trying to do is I am trying to fit it in a straight line. Okay, yeah, salary and years of experience can also be a good example. So when we talk about the math behind it, we have a formula which is called as y equal to mx plus c. So any idea? You would have seen or learned this in the school days or in maths, right? Remember y equal to mx plus c formula? Remember about y equal to mx plus c? Yes. So m here will be your gradient, which is going to be the difference in y by divided by the difference in x, and c is the intercept, which means, for example, this line, right? So if I extend it, okay, to cross the y-axis, so at which point it crosses this particular zero, okay, so that is going to be your c value, which is y-intercept. Okay, and the gradient difference in x divided difference in y divided by difference in x will be giving you the m value. So if you calculate, you will be getting y equal to mx plus c. Okay, so this is an example of used car data set where we have all the features. I have shown you previously this data set, right? So we have all the things, and we are going to, for example, let us consider we are going to predict the selling price, or let us consider we are going to predict what's the present price. Okay, sorry, we will be predicting the selling price. So let us go with that, and I have all these things, so let me consider only one independent feature, which is year. Okay, so if I plot it, we know that a used car, if the years used is very low, the price of the car will be really high, right? So you could see the negative trend in that. Okay, so this is the trend you could see. For example, if the age of the car is high, then obviously the price will be very low because it's a used car, right? Understood. So when you try to fit all the points and try to fit it in a straight line, okay. So what if I want to find, similarly here, what if I want to find, once I fit it in a straight line, if I want to find if my rainfall is 110 millimeter, what will be the umbrella sold, guys, here? If you understand this, you can understand linear regression, why we are fitting it in a straight line. If you fit it in a straight line, if I ask you that if my rainfall value is 110, so what will be my umbrella sold? It's simple, right? So you could draw a straight line and you could find that the value could be 30. Okay, so that's what the prediction is. That's what machine learning does in case of linear regression. Okay, understood about this, how linear regression is fitting every point in a straight line and then making predictions. 30, right? Very good, guys. So we have simple and multiple linear regression. So if I consider just one feature and try to fit it and try to find how it is related to selling price, then that is simple. Okay. So in case of multiple linear regression, I'll be taking care of car name, year, present price, fuel type, and all these features. and then I consider with selling price. So that will comes under multiple linear regression. Okay, so this is simple linear regression and multiple linear regression. So if you ask me, okay, fine. So I have my data set. I'm trying to plot a scatter plot and trying to fit it. You could ask me that this blue color line will also pass through majority of the points, and red color line will also pass through majority of the points, right? So how will you find the best fitting line here? How will you find the best fitting line here? Are you guys following this? Is it clear till now? So how this linear regression actually tries to find the best fitted line is, the whole idea of linear regression is to find the best fitting line which has very low error. Okay, here comes the value which is called as error, which will be really important in deep learning also. So that's why I have specifically kept linear regression and logistic regression here. So the whole idea of linear regression is to find the best fit line which has very low error value. Okay, and how, okay, so that can accurately predict the value dependent variable based on the values of independent variable. So what if, for example, here we told that if my rainfall is 130, sorry, 110, I have asked and you guys told 30, right? So what if my line passes somewhere else here near 40? So if I have a line which goes through this 40, so if I have 110, okay, if I try to find, it is telling me that umbrella sold is 40, right? So this line determines what is the output predicted. So it should be really important for you to carefully do this. So how this is obtained actually is, so the line of best fit is determining by minimizing the difference between the actual and predicted value of dependent variable. So this is how the error is calculated. For example, your algorithm tries to fit multiple lines and tries to find which has the lowest error. So what is that error? How that error is calculated is, for example, so this is my scatter plot. Okay, I have plotted my scatter plot and I have fitted a straight line. Okay, so this is my original value, but in this line it is depicted here. Can you guys see this? So this particular point stays here, but you can't have a straight line goes through all of these. So you find the best fit inside of it. Okay, so yeah, closest value, very good. So when you try to fit it, the original value is here, the represented value is actually here. So this difference is going to be the error. So if you calculate it for all the points, okay, you will be getting a summation of error. And which line, for example, if you have blue and red line, if blue line error is less compared with red, then blue is what you have to choose. Whichever has less error value, which means most of the points are nearer to that line, which is actually a good fit. So that's how linear regression works. So selecting the best fitted line, if the line passes exactly through all the points, then the value of error will be 0. So by comparing the error value of all lines, the line which has low error will be the best fitted line. Okay. So when exactly if all the points goes through this, the error will be 0, but practically it's not possible. Okay. So the best fitted line which has the low or anything which closest to 0 will be the best fitted line. And these are the formulas for simple and multiple linear regression. And this is the error formula, original value minus predicted value. If it's clear, I'll be going with logistic regression, and after that we can jump into deep learning basics. That's how in machine learning, mostly the linear regression helps you to find regression output. I told you, right, machine learning is just simple statistics. Clear, guys? Is it clear? Can we continue with logistic regression? So talking about logistic regression is much similar to linear regression, except how they are used. Where linear regression is used for solving regression problems, logistic regression is used for classification problems. Remember, if you are going to predict whether the temperature either hot or cold, or if you are just going to understand or predict whether it's a circle or triangle or a square, it is between classes, right? So that is comes under classification. Even though the name here, logistic regression, it is a classification algorithm. So how does that work? So in logistic regression, we instead of fitting a regression line, we are going to fit a S-shaped logistic function which predicts two maximum values, either 0 or 1. So that's what my output is, right? Either this or that, hot or cold. For example, whatever values you have, you are going to pass it from this formula of logistic regression 1 divided by 1 plus exponential of negative of that particular x value. So when you pass it, you will be getting logistic function. When you plot it, you will be getting a S-shaped curve. The output of this will be between 0 to 1. Okay. So when you have it between 0 to 1, what you does is, okay, I'll tell you what is this binomial and polynomial. This is a sample classification dataset of logistic regression. We have a lot of features, and here we are going to predict the passenger. This is a Titanic dataset. Their features, their details are here, and you are going to predict whether they have survived or not, whether they are alive or not. Okay, it is yes or no, 0 or 1. So here if you pass it, okay, in this formula, you will be getting a sigmoid curve which is between 0 to 1. So you have a threshold value here, okay. So you have a particular threshold value. So let me just show you that. This is the threshold value. So when you have a new point, you will be applying it in that formula. So if that value is below 0.5, then it is going to be declared as 0. Okay. And if the value is above zero point 0.5, then it is going to be declared as 1. So that's how you have threshold value, and you will be finding in logistic regression either the output is 0 or the output is 1. Okay. Clear? So in logistic regression, we use a concept of threshold value, and instead of straight line, we fit a sigmoid curve, and based on that we find. Okay, and here when we calculate the error, we use this entire cost function of logistic regression formula. So based on that, the error will be calculated. Okay, and for multi-class classification, what if instead of 0 or 1, if you have multiple classes like 0, 1 or 2, or either circle, square or triangle, in such case, what you will be doing is at one point of time you will be considering, you will be combining two of them. See here, this 2 is taken as 0 and this is taken as 1. And the next time you will be taking this as 0, these two as 1. So like that you will be performing binary classification. Okay, it is called as one versus rest. Okay, so the idea behind why logistic regression is based on probability is, see here we have a threshold value. We are making a probability that if it is above zero point 0.5, it is considered as 1. If it is below zero point 0.5, it is considered as 0. So that's why the threshold value and the probability, the word probability has been given. And finally, usually what we will be getting is, if you have multi-class, you will be having a probability distribution. From this, can you guys tell me which is the most probable one? Yesterday, I hope if you guys remember, we have discussed about argmax, right? So here, what will be the argmax output of this tensor array? Can anyone tell me in chat box? If you have listened yesterday's class, then I am pretty much sure that you will tell what will be the argmax output. First, tell me what will be the max output and what will be the argmax output. So that's why we have learned the argmax, and that's how when you have multi-class classification, you will be dealing it. Okay, the max value is 0.55, very good. It's not 3 actually, the index starts from 0, so it is 0, 1, 2. 2 will be your answer for argmax, okay? 2 will be your answer, very good guys, 2 is the answer. Okay, those who are gone with 3, you are pretty much near to it, very good. Still it is 2, okay? Max output is 0.55 and the index for argmax will be 2. If you sum all these things, okay, if you count the summation of this, the output will be 1. because they are distributing or telling you the probability. Someone asked that why logistic regression, they are telling it probability, right? This is what. Very good, guys, very good, and thanks for the response. And in between, before starting deep learning, so if you want, you could join as an internship user and convert this into a generative AI masterclass internship, 1 month internship, certified internship. So you'll be getting benefits in this internship: 30-day sessions, 90 days of access to it, source code of project, downloadable PPTs, 6 Zoom sessions where you can directly interact with me and clarify your doubts, internship confirmation letter, and then internship certification at the end. So if you want to avail this internship, you could join as an internship user by registering in the link which is given in chat box. So the discounted fee for this internship is around 899. So if you are interested and if you want to avail all these benefits, you could join as an internship user. The link is posted in the chat box. So we are particularly in day 3. We have discussed some machine learning basics. So if you want elaborative machine learning introduction contents and projects, you could join this internship. Apart from 21 days of generative AI, it has extra days or contents for machine learning basics, elaborate basics from Pandas library, and then other stuff still projects. The link is given in the chat box. And you will be getting the code, downloadables, PPTs, output files, model files for all these projects, which we are going to deal in the later part of this internship. I think we can jump into deep learning. So we'll see how much we can cover. We'll cover the basics of deep learning in this session. So before starting, I think I have already took what is deep learning, just a basic introduction we have done, right? Can you guys post down what is deep learning in chat box? We have seen it in day 1. If you guys remember, what is deep learning and what's the need for deep learning? Since we have machine learning, what is deep learning and what's its need? Can you guys post down the answers? What is deep learning? So deep learning is a subset of machine learning, some advanced version of machine learning, where instead of machine learning algorithms, we are going to use something known as artificial neural network to model and solve complex problem. So these are created to mimic our human brain, right? Very good, mimics behavior of human brain, subset of machine learning based on neural network, advancement of machine learning, automatic feature extraction, neural networks, advanced ML, very good, subset of ML, neurons, very good, guys, very good. Yeah, teaches computer to process data, very good, guys. So let us continue. So these neural networks are composed of many layers of interconnected nodes, which allows them to learn increasingly sophisticated representation of data over time. Over time means initially it fails, but when you train it over time, once again and again, you are making it to learn, it is going to improve itself. Okay, so how it's done? So this deep learning has been used to achieve state-of-art results. Nowadays, whatever you see in the AI, it is built based on deep learning concepts, okay, and neural networks, including computer vision, natural language processing, speech recognition, robotics, and all. I hope we have discussed elaborately in the introduction session, right? So now it's time for us to learn what is this neuron, what happens in this neuron, and what happens in our neural network. Let us understand. Can we start with neurons? Can I get a thumbs up emoji, guys, from your side in chat box? Can everyone post a thumbs up emoji just to continue? Yes? Yeah. So starting with neurons. So neurons are the basic building block of your neural network. Okay. So we have a lot of connections of neurons combined to form a layers or network. Okay. So here what happens is, I'll tell you a base and then I'll explain step by step. Okay. See here, I have input. Okay. So input will be x1, x2, x3, all the values which I have will be input. So what happens is when I pass it to my neuron, okay, or to my neural network, what happens is initially a weight will get multiplied to it. Okay, weight is something like a weightage. I'll tell you one by one. For now, I'm just briefing the concept. I have my input. When I pass it to my neuron, automatically it gets multiplied with my weight. Okay, this weight gets multiplied. Okay, and then something known as bias, a value gets added. Okay, and then it is summed and an activation function is applied, and then the output is generated. So this is what entirely happens in a neuron. Okay, what is weight, what is bias, how it's added, I'll tell you later. But for now, we have an input. This input x1 is multiplied with w1, x2 with w2 and so on, and then a bias gets added. Okay, weight is multiplied, bias gets added, summation is taken, and then an activation function is applied, and then output is generated. That's it. This is what happens in a neuron. But when you combine in a network, a lot of things happens. Let me tell you. Okay, so this is a perceptron, which is a single layer which gives you the output. Okay, and this is a neural network, which means you get all the inputs. Okay, so you are combining it seriously, a lot of layers. The initial layer will be called as an input layer, and the output generating layer is called as an output layer, and in between you will be having multiple hidden layers. Okay, deep neural network, and all the neurons does the same task. They get their input, does multiplication with weight, bias gets added, summation gets done, activation function is done, output is generated. So this guy gets the input from you, and he does some task, all those things, and then give output to this guy. He gets that as input, does the task, gives to the next one. So like that, the network passes information. Okay, so in a neural network, a neuron is a basic unit that receives input from other neurons or from external data, processes that input and produces an output signal. So the output of one neuron can be connected to the input of another neuron. Understood? The output of this neuron will be the input for this neuron, or the output of this will be the input for this guy. Okay? So the PPT is, if you want, you could join in the internship. It is only given for the internship users. So a typical artificial neural network consists of input layer, hidden layers and output layers supported by activation function, loss function and optimizers. Okay, now we are dealing with few more terminologies, right? Input layer we know, we have seen now. Hidden layer we have seen now. Output layer we have seen now. If you guys remember this activation function, we have seen it here. I haven't tell you what is that, but still we have seen that terminology activation function here. Okay, and then we are also given some other terms like loss function, optimizers. So what is that? Let me tell you. So these layers we have seen, input, hidden and output layers. This is a single layer neural network, and this is a multi-layer neural network. So what happens in a neuron singly? Let us understand one by one once again. So as I told you, we have an input, we have a weightage, okay, and then a bias gets added, and then a summation is done, and the activation function is applied, and the output is generated, right? So what is this weight and what is this bias? So weight represents the strength of connection between neurons. Okay, it is a scalar value that multiplies the input of a neuron to produces its output. So this weight gets multiplied with input. For example, let me just open a notepad and just show you guys. I hope you guys could see this. Okay, so for example, let my x1 value, let us keep it to 10. Okay, so I'm going to multiply with weight, which is first weightage for x1. I'm going to pass w1. So let me pass a value which is going to be 0.5. Can you guys tell me what will be the output here? What will be the output, guys? I don't know, please tell me. So next I have a value which is going to be 7. This is my x2 value. So I'm going to multiply it with a weightage of 1.0. Okay, so what will be the output? Here it is going to be 7, right? Here the output will be 7.0, and here what will be the output? 5, right? Is it 5? Yes, 5, right? So can you guys understand what does this weight actually does? It determines the weightage or importance of your input values. How important is x1? You could understand that x1 is actually 10, but when the weightage is applied, we could see that it goes to 5, right? But here the x2 value is actually 7, which is less than x1. But when the weightage is 1, it just converts into 7, right? So that's how this W is determining the weightage of each of your input. Okay. So what is this weight? How this W1 and W2 gets added, I'll tell you later. For now, I'm not going to tell you that. I don't want to confuse that. Just understand this weightage. And what is this bias then? As I told you earlier, this weightage will gets multiplied and bias will gets added. So with this input, I'm going to add some constant value. Let us add 2.0 as the bias. Okay, plus 2.0. So here the output is going to be 7.0 and here the output is going to be 9.0, right? So this is what your bias is. What's the reason behind this bias adding is, what if, okay, so you have an input of 0, your x3 is 0, let us consider, and you are going to multiply it with 0.4 weightage. What will be my output here? What will be my output here? So the output here is obviously going to be 0. Okay. So when you have a lot of input which is 0, it is going to like corrupt your neural network and your output may not be proper. So that's the reason why they are adding a constant bias value. Let us keep it to 2.0 here also. It is going to be constant at that time. So your output, if it is 0, your output will be 2.0. Okay, so that's why the reason behind bias adding. So now once you have, for example, if you have 100 inputs, all those things get summed here, and then a mathematical function like activation function is applied. It's just a formula, it will be getting applied and the output is generated. Okay, so the output is generated. Is it clear? I'll tell you about activation function later. For now, I just want confirmation from your side whether you understood how this input get multiplied with weight and how it's get added with bias and this process happening. What's the value? What is determining the weight and bias? I'll tell you later. For now, is the process clear? What happens in a single neuron? I just need a thumbs up or a yes or any confirmation from your side. This is important. If you understand this, then only you can understand how your entire thing works. Why this activation function? Good question. I'll tell you later. For now, I don't want to confuse this. For now, let us keep it simple. I have step by step. I'll explain activation functions. I'll explain all those things. Okay. So now if I tell you one funny thing, okay, how this weight and bias is determined means, obviously what is going to happen is when you initialize your neural network, what happens is this weight and bias are randomly generated. Yesterday, remember, we have seen torch.rand, some random numbers generated, right? Your neural network starts with just a random number, okay, and what happens is over time they are going to adjust that random number so that your output is going to mimic your original output, okay, your prediction. So that's what the continuous learning over time is. They start with a random weight value and random bias value and then they process. I'll tell you later on. Okay, so this what happens is, see here, a weight and a bias gets added, everything is done and the output is generated. Okay, so this is called as a forward propagation. Activation function is applied, this happens in every neuron, they generate output, this is given here, this is given here, this process goes on. Okay, this weight and bias are actually randomly generated numbers at the beginning. Okay, and then what, this is what a forward propagation is, which means that there is something known as backward propagation, which is the backbone of your neural network and deep learning, guys. Okay, so we have our input, weight gets multiplied, bias gets added, the process goes on and it will give you the output. It's the process of passing data through a neural network to produce an output. So now we are going to discuss what is a loss function. Remember, here we have seen something known as a loss function terminology. Loss function. So what is this loss function? Let me tell you now. Okay. So loss function is nothing but once the forward propagation is done, you will be having an output predicted by your neural network. They have just started with a random number. Obviously, the output is going to be terribly bad. Okay. So this loss function will compare your original one and the predicted one. So now we are evaluating our neural network. We are going to tell that you have done really a terrible job. Whatever you have done, it's really bad, because at first it will be a random number. So the output will be very bad. So it is going to compare. So this is what a loss function will do. It's a mathematical function that measures the difference between the predicted one and the actual output. No, there is no limitation. There will be only one input layer possibly and many hidden layers. That's optional. You can have multiple hidden layers. Okay. And neurons count also, it is going to be optional. So if you increase the neuron count, then the mathematical calculations will increase, and your computation energy and time spent will also be increased. That's it. Okay. So this is what loss function will help you to do. It finds how bad your model is performing. What's the error? This will find you what's the error. So once the error is done, we are going to go to something known as back propagation. So this is where exactly your neural network learns to improve itself. So once you tell the neural network that you have done a bad job, okay, you have done a terribly bad output, this performs something known as back propagation. So in this back propagation, what happens is, you guys remember initially we have added a random weight and bias. Okay, so this random weight and bias, based on your error, this is going to get adjusted. Okay, very minimally it will get adjusted. Okay, so it will try to fit. Okay, it seems like, okay, it is going to understand that it seems like the x1 I have given 0.5, right? It's a big mistake. If I go with 0.9, what will be my output? It is going to be 9.0, and this is going to be 11.0. So if your neural network does this, and if the error is less, then the neural network understands that this zero point 0.9 may be a good weightage for this x1. Okay, so like that, what happens is, when you perform this back propagation, your weight as well as bias, which you have randomly given, okay, you have your original output. What we do is, we'll be giving the questions as well as the answers to your neural network. When it trains or when it learns, it will be having a set of original answers, and it will be having the predicted answers by itself. So using max, we have some formulas. We will be comparing what's the error value, like we have done in linear regression. Remember the error calculation, what's the original value, what's the predicted value. That's why we have learned linear regression. Okay, so through back propagation, the weight and bias gets adjusted. Okay, so how this weight and bias are actually adjusted, what's the math behind this? I'm not going to give you some complex maths. I'll tell you very lightly. We have something known as optimizers to do this task. So these optimizers are algorithm that are used to adjust the weight and bias, okay, in a neural network during training, so with the goal of minimizing the loss or minimizing the error. So the weight and bias are updated via chain rule of differentiation. In max, we have a derivative which is called as chain rule of differentiation. Look into it. Okay, please note down that and look into it. That's what used to update your weight and bias. So optimizers uses a hyperparameter known as learning rate, and that is used to control how or which step should be taken for optimization. So the ultimate goal of an optimizer is to, in deep learning, is to minimize the loss or error and achieve the best possible result. So he is like, optimizer is going to be the character, or he is going to be the teacher. He tells our neural network that you have done very bad job, so just go and learn once again. And he is going to give feedback, or he will help him to adjust the weight and bias so that over time it improves. Okay, clear? Is it clear, guys? So if it's clear, I can tell you what this gradient descent optimizer does, what's the formula, how it's done, and all. And in the meantime, so if you want to convert this masterclass into a certified internship on generative AI, you could join as an internship user, and you'll be getting 30 days of live sessions, 90 days of access to it, source code of projects, downloadable PPTs, data sets, code files, model files, output files, Zoom sessions, 6 Zoom sessions where you can directly interact with me every week and clarify your doubts, internship confirmation letter, and internship certification. So if you want to avail this in this discounted fee, make it as soon as possible. It will be a limited time offer, and the fee is 899, and the link is given in chat box. These are all the topics covered in this internship. Along with that, basics of machine learning will be given as additional content for the internship users. Yeah, so continuing with that, so I told you, right, optimizer will helps you to adjust the weight and bias. So let me show you an optimizer which is called as gradient descent optimizer. Okay, so when you have multiple hidden layer, if it is actually required, then it won't be affecting your model's performance. But sometimes what happens is if you have a lot of multiple hidden layers, okay, what happens is it may lead to overfitting. Overfitting, if you are familiar with machine learning, you could understand what a overfitting is. So in overfitting, what happens is your model or your neural network fits more towards your training data, so that when you give a new data it fails. Okay, in your training data, it, for example, it's like a student who is very good in the questions asked in the book, so he will learn that questions and answer that questions. So when you ask a new question or a creative question, that student terribly fails. Okay, so that's what overfitting is. It learns on your training data good. So if you have multiple network, it learns too much, so that it may lead to error. So coming into gradient descent optimizer, it is an optimizer which will help you to adjust your weight and bias. For example, let us consider this is your weight, okay, and this is your loss value. Y-axis is going to be your loss. So initially my loss is here, which means I have a high loss, and this is called as minima or global minima, which tells that at this particular point the loss value or error is very low, and you are going to find, you want to find an optimal value. Okay, so if your weight and bias you have randomly generated, right? So initially the loss will be here or there, but you want to take slow steps to reach this global minima, which is very low error, which is optimal weight and bias. To do this, we have a gradient descent optimizer. So what happens is, this is the exact formula used by your optimizer. Okay, your new weightage and new bias, just replace weight with bias, you will get the formula for bias. So new weight and bias is determined from subtracting the old weight minus the learning rate. I told you that there is a hyperparameter here called as learning rate that is used to adjust. I'll tell you what is the use of it. So this learning rate gets multiplied with the derivative of error with respect to the weightage. Okay, so when you apply this particular formula, you will be getting a new weightage. Okay, and then this learning rate is going to determine whether you want to, for example, if the learning rate is 0.01, then once you improve it, it is going to just take a little step. If you have a learning rate of 10, what happens is it is going to jump here. But if you understand, okay, if you jump here and there with high learning rate, your loss will be jumping here and there, but it can't reach this global minima. So if you want to reach this part, you have to have a very low or little learning rate, so that it takes an incremental step. It can be either here or here. Okay, so if your weight or if your weightage you have, for example, if your error or your that output derivative is here, okay, if your loss is here, which is to be the left side of your global minima, so this output will obviously give you a negative value. So if you have a negative value here, for example, if this derivative is negative, what happens? Negative multiplied by negative will become positive. So your old weight gets added with the new value. So your weightage, new weightage will be higher than your old value, which means when you add, okay, what if your old weight is here? Okay, this is going to be, okay, the derivative will be negative, negative multiplied by negative will be positive, so the new weight will be a higher value, which means it will move here, okay, somewhat here or here or here, right, which will move towards your global minima. That's the idea. Okay, or what if your value stays here, like here? If it is here, then the slope value or this derivative is positive, which means if this is positive, you are going to subtract from your old weight, so your new weight will be a lower value than your old weight. Okay, so what happens when your new weight is going to be older, so less value than your old weight, this decreases, right? So obviously this will try to converge into this global minima. Yes, very good, it is gradually decreasing. So the idea is to gradually decrease the error. Okay, so that's how the back propagation works. So it starts with a random number, get the error, and using this optimizers, it is going to adjust, okay, and try to converge to this minimal point. So either if it stays here or here, based on this derivative, it is going to be a positive or negative value. Multiplied with this learning rate, it is going to give you a new weightage, which is either increasing or decreasing, so that obviously you need to reach this global minima. Okay, and the chain rule of differentiation is done. The learning rate should be actually very low value, like 0.01 or something very low value. So based on your data you will be determining. So initially you will be going with a learning rate of very low. Even if it's very low, which means that this can't adjust too much, it will be stagnant here. So we need to implement it practically and decide based on our data. So this is the back propagation, new values gets, for example, new weightage, new bias, and then back propagation, new W1, new W2, new W3. So with that new weightage, this goes once again. Okay. So this process of forward propagation, input with multiplied by weight, bias gets added, activation function is applied and the output is generated. And in back propagation, from output loss is calculated, optimize is used to adjust, okay, and then the new weight and bias are determined, once again the forward propagation happening. So it is going to be a loop of forward and backward propagation leading to improvement. Okay, so this is what happens in your neural network. Forward and backward propagation happens for multiple times so that the error decreases. Till the error decreases, if you do it, obviously it is going to learn best, right? So if you want this PPT material, I just tell you that you can join this internship by using the link given in chat box. You will be getting all the benefits, and it's only for the internship users. Sorry. And this is what a forward propagation and a backward propagation is. Okay, next we need to discuss about the types of activation function, loss function, optimizers, and how to select these things. Okay, and I think if we start now, we can't complete this. So I want to take it entirely. So the remaining things we'll just keep it for now, and we'll see in the next session. Okay, so we'll continue the remaining things like different types of activation functions and loss functions and optimizers. And after completing that, in day 4 we'll learn, okay, how to build a basic neural network with Pytorch. Any other doubts, or can we see in the next session? So if that's it, thank you guys, thank you for watching. We'll see tomorrow on day 4. Please keep the same spirit. You guys are posting a lot of answers in chat box and being interactive, so I just want to continue this till day 21. So if you continue this day 21, I can assure you that you can be a pro in deep learning and you can be a good beginner in your generative AI. Okay, we will be providing for the internship users the PPT, the code, downloadables and all will be given. So if you want, you could join as internship user, or if you can't, you want to just learn, you can watch it free on YouTube. Bias is a constant value. Thank you for your good comments, guys. Thank you so much. Thank you all. We'll see tomorrow. We'll see the continuation and we need to see how to do it with Tensor and with Pytorch, how to build it in neural network. And that will lead us to day 5 with the project of machine learning and day 6 of project. Thank you all.